Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here coming with a fantastic chemistry video, and today we're going to talk about drawing Lewis structures from molecular formulas, a very fundamental question. You're going to have to know how to do this. Pretty much everybody asks this question on the first exam. It's important. It's never going to go away. Looking at Lewis structures, looking at organic structures is fundamental, not only in chemistry, but in biochemistry, biology, even physiology, maybe even in physics, depending on what you're taking. Okay? It's fundamental. So you may as well learn how to do it and do it correctly every time. Remember the octet rule. Every atom wants to have 8 electrons, or in other words, every atom wants to have a filled valence shell. Now, we're speaking pretty much strictly about nonmetals. They stop at 8. Now, are there nonmetals that can go above 8? Absolutely there are. Are there nonmetals that want less than 8? Yes, it's hydrogen and helium. They want less than 8. Basically, we're talking about filled valence shells. Now, all this is kind of a mystery to you. Go back and review your general chemistry notes on electron configuration and valence electron theory and octet theories, okay? Because this should be something that you already know. Now, let's go after this one, CH4. How do we draw the Lewis structure of methane? Well, you have to know how many valence electrons each atom has. So carbon, I know, has 4. If you don't know why, it's part of the group number. It's in group 14 or 4A, so I know it has 4 valence electrons. Hydrogen's in group 1 or group 1A, so I know it has 1 valence electron. I know that hydrogen wants to have 2 electrons because that will fill its valence shell. I know carbon wants to have 8 electrons because that will fill its valence shell. I also know that every time you make a bond, 2 electrons have to come together. So a hydrogen brings an electron, a carbon brings an electron, they form a covalent bond together. So now, once you make a covalent bond, you can recount your electrons. And remember that every single bond counts as 2 electrons. So this is 2 electrons right here, 3, 4, 5. So carbon had 4, now it has 5. So it seems like, and it's true, every time you make a bond, you're giving an atom 1 more electron. So this hydrogen wants to have 2. So you count the single bond as 2. They're quote unquote sharing the electrons. So now that's nice because that gets rid of my carbon and one of my hydrogens. So let's make another bond to hydrogen. Remember, hydrogen brings 1 electron, carbon brings the other. 2, 4, 5, 6. We're getting there. Let's keep adding hydrogens. Hydrogen here and another hydrogen here. 2, 4, 6, 8. The carbon now has an octet. It has 8 valence electrons. The hydrogens each have 2 electrons. So that is a satisfied valence shell for hydrogen and a satisfied valence shell for carbon. Carbon has 8 electrons. Each hydrogen has 2. Okay? And that's how you would draw the Lewis structure of a small molecule like methane. Just do it like that. That's how I do it. Now, you may have another way you learned in high school or in general chemistry. As long as it works, use that way. That's completely fine. All right. Ammonia. We know nitrogen has 5 valence electrons because it's in group 5A or group 15. Hydrogen each has 1. Hydrogen wants to have 2. Nitrogen wants to have 8. It already has 5, so it's going to want to make 3 more bonds to something. It doesn't have to be hydrogen, but in this case it does because it's ammonia. We're working with NH3. But nitrogen can bond to any other nonmetal. In this case, it's hydrogen. So let's bring the nitrogen out. And we know we can make a bond with a hydrogen, right? There we go. There we go. There's 1 bond. 2, 4, 5, 6. So we're getting there. Every time we add an atom and a bond, we're adding 1 more electron to the ammonia. Another one here and another one there. Takes care of those. 2, 4, 6. Lone pair counts for 8. So the nitrogen has 8 electrons. It's a satisfied octet. Nitrogen's interesting because it's the first atom in the periodic table that can have a lone pair. Have a lone pair and be neutral. Okay, carbon can have a lone pair too, but it will be negative, of course. Let's keep on moving down the row. Water. Oxygen has 6 valence electrons. I know that because I know that because oxygen's in group 16 or 6A. So it has 6 valence electrons. Hydrogen, of course, wants to have 1. So water will make a bond to 2 hydrogens. 2, 4, 6, 8. The oxygen has 8 electrons. Every hydrogen has 2. The octet rule for water is satisfied. The octet rule for oxygen, I keep saying water. The octet rule for oxygen is satisfied. The octet rule for hydrogen, or the duet rule, is satisfied. So this is how we come up with these structures for these molecules. Now, all the rules you've learned for these small molecules apply to larger ones. Okay? Just because we're using small molecules here doesn't mean the rules don't apply to the larger ones. They certainly do. All right, guys, now if you found this video helpful, please go ahead and slap that like button. Leave a comment down below. Let me know how you can be helped with my videos. Let me know if I can do a specific problem that you're working on in your chemistry class, and I'd be glad to help you out. And if you would, please subscribe to my YouTube channel. It really does help out creators when you guys do that. Keeps our channel growing, keeps us motivated to keep making more and more content for you guys. Now, with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.